Factoring by grouping. This skill will allow us to factor a lot of different, more difficult trinomials. So let's take a look at, pardon me, a polynomial. Let's look at the quantity x plus 2 times x plus the quantity x plus 2 times 10. So take a look. We're looking for the GCF. Do you remember what GCF stands for? Greatest common factor. So what is the largest factor that we can divide out of both terms? Looks like we can divide an x plus 2 out of both terms. So if we divide both terms by x plus 2, so if I divide this guy by x plus 2 and I would divide this one by x plus 2, the factors divide out. So here I am on the outside times the quotient is x plus 10. Looks like things that we've been working on, huh? So when you've got a GCF, it needs to be factored out of both terms. So let's use this idea to work on some more difficult trinomials that we need to factor. Let's take a look at, actually, we're not going to do trinomials. We'll do a polynomial, 4-term polynomial. So let's look at this one. Let's do, we're going to factor ax plus 3a plus x plus 3. All right, so let's group it. Let's group it into two groups of 2. So there's that group of 2 and there's this group of 2. The GCF for the first group, we can divide out an a, so that leaves x plus 3. The second group, there's no GCF. If there's no GCF, then the GCF is 1, positive. And then we are left with x plus 3. Now let's look for GCFs again. We've got 2 terms. What is the greatest common factor of these 2 terms? It's an x plus 3. And when we divide out the x plus 3, we have an a plus 1 quotient. And that's how that works. So let's extend it one more time. And let's take a look at changing a trinomial into a 4-term polynomial. So 3x squared plus 5x plus 2. So right here, take a look at that 3 that is a coefficient in the front of the leading term. So let's go back to our diamond for a second. We need to find, remember we did firsts when we multiplied. So actually we're going to have, our firsts are going to have to include this 3. So 3 times 2, so factors of 6 that add to equal 5. I feel like I've done this one before. All right, 6 that add to equal 5, so 2 and 3. So we're going to split this 5x into a 2x plus 3x, or a 3x plus 2x. Remember, addition is commutative. I might do 3x times 2x. Doesn't matter though, you'll get the same answer. So here we go, we've got a 3x squared plus 2x plus 3x plus 2. Is it the same thing as this one here? Yes, it just kind of goes against our sensibilities of simplifying. All right, let's group it into 2 groups of 2. So the GCF for the first group is x. So I've got 3x plus 2, and the GCF for the second group looks like positive 1, so 3x plus 2. GCF between these 2 terms is 3x plus 2, and when I divide that out, the quotient is x plus 1. All right, so that is how you would factor something like this. All right, it's been a little while. So take your time, go slow on these practice problems and make sure you've got it and check your work as you go. I'll see you next time.